pale glimmer drifts through space, silent, cold, and uninvited. No radio waves, no orbit, no allegiance to the sun. Through the dark fabric between the stars, an object moves. Not bound, not captured. Astronomers name it 3IATLAS. At first it seems like a comet, but the closer telescopes look, the stranger it becomes. Its gases don't behave like ice. Its light bends in unexpected colors. Its chemistry whispers of a world beyond our solar system, and perhaps a kind we've never seen before. Tonight, we follow the 7 anomalies that make 3IATLAS a mystery, and explore why NASA and astronomers across the world quietly admit this is no ordinary comet. It began quietly. In July 2025, the ATLAS survey in Chile detected a faint moving point against the stars. At first glance, it resembled any icy wanderer making its long journey toward the sun. But within hours, its trajectory revealed something unusual. It wasn't looping around the sun. It was cutting straight through the solar system, on a hyperbolic path that would never return. Astronomers recognized the pattern instantly. Only 2 objects before had shared that signature. Oumuamua, discovered in 2017, and Borisov, found in 2019. This new traveler became the third, 3IATLAS, the third known interstellar visitor. Within days, the world's great observatories turned their eyes toward it. Hubble, JWST, SphereX, Gemini, the Very Large Telescope in Chile. Each one captured faint glimmers of an alien traveler gliding through our neighborhood. At over 400 million kilometers away, it already displayed a hazy coma, a glowing envelope of gas that suggested it was active long before sunlight should have warmed it. And so began the puzzle. 3IATLAS was doing things no comet should be doing. Every new observation only deepened the mystery. And soon, astronomers listed 7 distinct anomalies that challenged everything we knew about comets. Anomaly number 1. Activity in the frozen zone. Most comets remain dormant until they draw near the sun. But 3IATLAS was active far beyond the frost line, out where even carbon dioxide remains solid. Its coma was already glowing, implying internal energy or exotic ices unlike any in our solar system. Something deep within was boiling in the cold, a signal that this wasn't an ordinary comet of frozen water and dust. Anomaly number. The CO2 dominant spectra from JWST revealed something astonishing. Instead of water vapor dominating the gas plume, 3IATLAS was releasing carbon dioxide in overwhelming amounts. The ratio was unlike anything seen before. A CO2-rich object whose chemistry looked more like the outskirts of a dying star system than a typical comet from the Kuiper belt. This hinted that 3IATLAS may have formed far from its parent star, in a frozen cradle beyond the reach of warmth. Or perhaps it came from a system where water was never abundant at all. Anomaly number. A tail without dust photographs showed a faint, wide tail sweeping away from the sun. Yet measurements revealed a strange imbalance. Gas output was high, dust output was not. Ordinary comets eject both in tandem. But here, dust lagged far behind. The tail was faint, almost translucent, as if the nucleus were venting pure vapor into space. Was this because the dust was unusually heavy, or was it missing altogether, replaced by metallic or glassy grains unseen in typical comets? The data refused to fit known models. Anomaly number 4. The nickel signature. Then came the shock. Spectrometers detected traces of nickel vapor, but little iron. In comets, nickel and iron usually appear together, born from the same rocky minerals. Here, nickel emerged first, stronger and strangely isolated. That suggested high-temperature processes, as if the object had once been forged closer to a star, then hurled outward. Even stranger, cyanide emissions were detected simultaneously, a combination never before observed in interstellar objects. This was no random fragment of ice. It was complex, layered, chemically ancient. Anomaly number 5. The green transformation. By early September, skywatchers noticed something unexpected. The once pale comet began glowing green. That hue usually comes from diatomic carbon, molecules broken apart by ultraviolet light near the sun. But in 3IATLAS, The green appeared earlier than physics predicted. It meant the comet was generating new compounds as sunlight struck its alien ices, compounds we have never seen in local. Met's the transformation was visual proof that 3IATLAS carried a chemistry that evolved differently. Under starlight, a living experiment of another planetary system's chemistry, unfolding before our eyes. Anomaly number. The perfect alignment. Next came the question of its path. 3IATLAS traveled almost perfectly along the ecliptic, the same flat plane in which most planets orbit. For an interstellar object entering randomly from the galaxy, this alignment was statistically improbable. It fueled debates among scientists. Was it coincidence? Was gravitational focusing responsible? Or could its trajectory hint at something intentional, perhaps shaped long ago by an encounter we don't yet understand? NASA dismissed wild claims of alien probes, but the geometry remained a puzzle that data alone could not easily explain. Anomaly number. The fire hose effect. Finally, as it neared 3 AU from the sun, instruments recorded 3IATLAS ejecting water at 40 kilograms per second, a torrent comparable to a high-pressure hose in space. Yet at that distance, ice should barely sublimate. No known heat source could drive such a rate. It suggested deep fractures, vents, or volatile pockets erupting under weak sunlight, or perhaps internal energy trapped for eons now finding release. For planetary scientists, this was the most startling clue of all. Whatever 3IATLAS is, it's governed by internal physics we don't yet comprehend. Together, these 7 anomalies formed a mosaic of contradiction. Every line of evidence said comet, but every number refused to agree with the definition. For months, telescopes tracked it as it swept through the inner system, its glow brightening and fading, its chemistry changing with distance. Each mini-reveal only deepened the central question. If it walks like a comet and shines like a comet, why does it behave like something else entirely? When the data reached NASA's Planetary Science Division, the tone was cautious but intrigued. 3IATLAS, they said, was forcing a rewrite of what comet even means. Scientists proposed that it might have formed beyond the CO2 ice line of its home star, in a region colder than any place in our solar system. Such an environment would explain its carbon dioxide dominance and its early, distant activation. Others suggested it might be the shattered core of a planetesimal, a fragment blasted from a young planetary system during violent formation. Nickel-heavy gases hinted at thermal alteration. Perhaps it once orbited closer to its star before being thrown outward into the galactic void. Chemically, it appeared ancient, possibly older than our sun itself. Its isotopic ratios pointed to low metallicity, a fingerprint of stars born in the Milky Way's thick disk, billions of years before Earth even existed. If that's true, then 3IATLAS carries the chemistry of a time long lost, a frozen relic of the galaxy's youth. It also exposed how limited our understanding of cometary diversity truly is. Every previous model assumed comets across the galaxy behave like ours. Atlas shattered that assumption. Its faint dust, early gas release, and chemical imbalance revealed that nature can build icy bodies in endless combinations, each shaped by unique stellar nurseries. The alignment puzzle, too, sparked quiet reflection. While coincidences happen, scientists noted that our sample size, just 3 interstellar objects, is too small to draw conclusions. Still, the near-perfect orbital match with our ecliptic remains a mystery that defies easy probability. Finally, its immense water loss raised the hardest question: how much energy hides inside a comet's heart? Could radioactive decay or trapped crystalline transitions power these outbursts? Or does 3IATLAS hold some internal reservoir yet unseen? For NASA, ESA, and observatories worldwide, one message became clear. The next time an interstellar visitor appears, we must be ready to intercept, not just observe. Because with 3IATLAS, the chance slipped away too fast. Its speed, over 60 kilometers per second, made pursuit impossible with any current spacecraft. By the time it was confirmed interstellar, it was already racing past the sun, leaving only data and wonder in its wake. Out there, Beyond the solar wind, 3IATLAS fades, a faint dot, shrinking into the dark between stars. It came uninvited. It left unchanged. But for a brief season, it offered humanity a window into the unknown. 7 anomalies, each a whisper that our solar system is not the template of creation, but one of countless variations scattered across the galaxy. Its chemistry, its color, its silence, all tell the same truth. The cosmos is stranger than we think. In 3IATLAS, we glimpse not a comet, but a messenger, a frozen archive from a system that lived and died long before ours began. And as it drifts away, we are left with a quiet realization. The universe does not run out of mysteries. It sends them to our doorstep. Every grain of dust, every molecule of gas from 3IATLAS is a fragment of another world story. And when the next interstellar traveler arrives, we will be waiting, ready to listen. Because in the end, these visitors remind us that we are not isolated in the dark. We are part of a greater cosmic conversation, written in ice, carbon, and light.